Okay, so let me kind of give you some different techniques you can use on these graphic, or these vectors with trig functions, okay? Because we're going to use it literally with forces, with optics, with electric fields, with magnetic fields. So this is something, hey, we're going to study this today, and it's a skill that we're going to get, and then we're never going to touch on it again, okay? We use it so extensively through physics. So here's the story. So let's say, for example, you have number 13. I'm going to show you, if you just gave me number 13, said, hey, Burkamp, how are you going to work this problem? This is what I would do. First thing I would do is I would just make a sketch of what we call the free body diagram. Free body diagram says, here's this object, whatever it is, a squirrel, a box, pick an object, okay? And I got a 5 Newton force here at 60 degrees. And then I've got a 60 Newton, or 10 Newton force at 60 degrees. And then I've got a 10 Newton force at 80 degrees. Okay? So, this is the free body diagram sketch. Okay? This is not tip to tail. This just says, hey, here's a soccer ball. Danny's kicking it this way. Cohen's kicking it that way. Where's the ball going to go? So clearly, what does that angle have to be between?
0 and 90 degrees, or the two angles. But
Yeah, somewhere between 60 and 80. Okay, I know that my angle has to be somewhere between 60 and 80. Okay, without fail. Is it going to be closer to 80 or closer to 60?
Probably closer to 80,
Why?
because there's more force in that direction.
Yeah, so right away I know my angle is probably going to be closer to 80 degrees. So if I don't get that, if my angle doesn't fall within those two parameters of 60 to 80 and closer to 80, I've done something wrong. Okay, that's it. So the other thing, and literally, if you look at this answer key, I've got charts. And I've got charts because of the fact that it forces you to be organized. So here's the main idea that you got going. You're going to go in here and you're going to find the X and Y components of both of these. Okay? So you're going to have this chart over here that says, here's my 5 Newton force, here's my 10 Newton force, here's the sum of these values. Here's my X, here's my Y. Okay? Main thing, it benefits you because you got to go, oh, here's my thought process. It also makes it easy for me, so in case something has gone south, I can look at it and go, okay, hey, where did we screw up? Was it the X values? Was it the Y values? Was it the sum? Did you miss a negative sign? Okay? Now, this one's relatively easy because everything is in the positive first quadrant. So all your X's are positive, all your Y's are positive. You don't have to worry about anything like that. So again, here's what's important. You got your X and Y. I'd come in here and go, okay, once you get those, make a new sketch. Going, your X sum should be around 4. Your Y sum should be around 14. You're going to use the Pythagorean theorem to find your resultant, and then I'd use inverse tangent to find the angle. So, on number 13, the magnitude should be around 15 newtons, and the angle should be, oddly enough, a little bit less than 80 degrees. Okay? That one wasn't bad, because everything was in the first quadrant. Now, 14 is a little sketchier. So when you get to number 14, again, come in here and go, okay, I got 5 newtons at 100 degrees, and then I've got 10 newtons at 200 degrees. Okay? 10 and 200 degrees. So this is going to get sketchy because that 5 Newton force has a negative X and a positive Y. The 10 Newton has a negative X and it has a negative Y. And it's not in the first quadrant, and you have to decide which you're going to do. But again, think this through. Start with this idea. what does your angle have to be between?
100 and 200.
100 and 200. Your angle has to be between 100 and 200. Closer to 200, closer to 100.
Closer to 200.
Because that's the bigger force, okay? So right away, if your angle isn't within that parameter, you've done something wrong. So all of these have 3 significant digits. So when you calculate any x and y component, keep a minimum of 3 significant digits on you. Now, here's the choice that you need to make. If you look at that 5 Newton force at 100 degrees, you can either work off the 100 degrees, or you could come out here and work off that 80-degree angle and use the 80 degrees to find your x and y components, okay? I care not which one that you do. Personally, I'm old school just because I learned from those charts. My chart stopped at 90. I couldn't look up 100 degrees, but I could look up 80 degrees, okay? So that's what I would work off of. So if all goes well on number 14, the force should be around 10, and the angle should be about 100 degrees more than your answer to number 13. I wish I was clever and I had that planned. I wasn't. Okay. Any questions? Attach the diagrams that went with that first start. Attach that to the back. Get those handed in. Cohen, stop yonder camera.